So we need to describe the motion of the particle whose position function is given. And to do that, we need to find the velocity first, which is the derivative of the position. And the derivative of the position is the derivative of t, which is 1. And then the derivative of this quotient, we know to use the quotient rule. So we're going to use low d high, high d low. And low, which is t plus 1, d high, now the derivative of the constant is 0, minus high, which is the numerator. D low, the derivative of t plus 1 is just 1. And then over low squared, so that's over t plus 1 squared. And then plus 0, because the derivative of 1 is 0. And now, we don't want to leave it like this. It'll be easier to get this as one fraction, because when we get it as one fraction, then we can determine where the velocity is 0. That's what we want to find. And we also want to find when the velocity is positive and negative. So that happens much easier, like I said, when we can express the velocity as one fraction. So currently, this first term in the numerator goes away, and we have minus 9, and then over t plus 1 squared. So we need a common denominator of t plus 1 squared. So we have t plus 1 squared over t plus 1 squared, and then minus 9 over t plus 1 squared. So then we combine the numerators, t plus 1 squared minus 9 over t plus 1 squared. And then still not super able to determine when the velocity is equal to 0. So we're going to multiply this out here in the numerator, t squared plus 2t plus 1 minus 9. That's the numerator. I'll just put dot 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 for the denominator. And then combining like terms in the numerator, we have t squared plus 2t minus 8 over the denominator. And then factoring the numerator, we can see we have t plus 4 times t minus 2 all over t plus 1 squared. And we'll leave it like that to determine whether the velocity is positive or negative, but we also then will write it all, we're going to multiply everything out, both numerator and denominator, because then we also need to find the acceleration, which is the derivative of the velocity, and it'll be easier to do that when both the numerator and denominator are multiplied out. So we have t squared plus 2t plus 1, and we're going to leave it like this for now. And then we're also going to find the acceleration. So we'll do that first before we determine where the velocity is equal to 0. And let's do this so we can now move down here to find the acceleration, because we always know we have to find the acceleration velocity. We want to determine whether the particle is speeding up or slowing down. So acceleration we know to be the derivative of the velocity. And the derivative of velocity is the derivative of this fraction here, this quotient. And again, we have low d high, high d low. So we have low t squared plus 2t plus 1, low d high, and the derivative of the numerator is 2t plus 2, minus high t squared plus 2t minus 8, d low, 2t plus 2, 2t plus 2, all over low squared. Now, I can now use this here because I've got if I take t plus 1 squared and square that, I get t plus 1 to the 4th. So just a little bit of strategy here will help you minimize the amount of algebra that you have to deal with. Now there's a couple options here. One option would be to factor out the 2t plus 2's from both terms here. But again, just a little foreshadowing, if I notice here, when I multiply, if I were to multiply these two out and then these two out, then I would get 2t times t squared, that's 2t cubed, and I'm going to have a minus 2t cubed. So that makes me think, well, maybe I can just multiply these out, and then my 2t cubed will go away, and maybe it'll be easier than factoring out the 2t plus 2, but you could also do it that way. So I'm going to go ahead and multiply these out. And in saying that, I'm looking here, and it's going to take a lot of work to do that. So I'm just going to go ahead and factor out the 2t plus 2. 2t plus 2, if I factor that out, I get t squared plus 2t plus 1 minus t squared plus 2t minus 8. Yeah, I think that might be the best route to go. T plus 1 to the fourth. And then at this point, I could also factor out a 2 from this first factor here, and I'll go ahead and do that. 2 times t plus 1. And then inside these parentheses, I've got t squared. Let's go ahead and multiply everything out. I'm going to distribute that minus sign so everybody's clear. I'm going to distribute the minus sign. And then that's all over the denominator. And I have 2 times t plus 1. And then t squared minus t squared, those go away. 2t minus 2t, those go away. And then I have a 1 plus 8, that's a 9. And then over t plus 1 to the fourth. Oops. And then I can cancel one of those t plus 1s. So I have 18 over t plus 1 cubed. So that expression right there, that's the expression for the acceleration. So that's acceleration as a factor, as a function of t. So now we have that, and I will proceed in the next video with the rest of the problem.